let's look at this problem. Find the value of pi k equal to 3 to infinity 1 minus tan power 4 pi by 2 power k. So pi k equal to 3 to infinity 1 minus tan power 4 pi by 2 power k. Okay, first we'll simplify this part, or the one which is inside the brackets, 1 minus tan power 4 pi by 2 power k. Okay, so this is 1 minus sin power 4 pi by 2 power k by cos power 4 pi by 2 power k, right? So if I take LCM, cos power 4 pi by 2 power k minus sin power 4 pi by 2 power k by cos power 4 pi by 2 power k. So this is cos square minus sin square into cos square plus sin square, because a square minus b square, right? So a plus b into a minus b. So cos square pi by 2 power k whole square minus sin square pi by 2 power k whole square by cos power 4 pi by 2 power k. So a plus b into a minus b. So cos square plus sin square is 1. So cos square pi by 2 power k plus sin square pi by 2 power k into cos square pi by 2 power k minus sin square pi by 2 power k by cos power 4 pi by 2 power k. So this is 1, and cos square minus sin square is cos 2 theta. So this is cos 2 theta. So 2 into pi by 2 power k by cos power 4 pi by 2 power k. So this is cos pi by 2 power k minus 1 by cos power 4 pi by 2 power k. Okay, so this is what we got. So what we do next is, so we'll expand pi. So pi is k equal to 3 to infinity. What we got is cos pi by 2 power k minus 1 by cos power 4 pi by 2 power k. Okay, first in order to solve this, what we do is, instead of k is running from 3 to infinity, we'll make it from 1 to infinity. So that we don't have any problem in calculations. So if I want to make it from 1 to infinity, so k is, we have to replace k. So how should we replace k? So that, so k is equal to 3, no? So we have to make it to 1. So let's say I will replace k as t plus 2. So now t runs from 1. So and k tends to infinity, t is also tending to infinity. So pi t equal to 1 to infinity cos pi by, instead of k we have to write t plus 2. So t plus 2 minus 1 by cos power 4 pi by t plus 2. So this is pi t is equal to 1 to infinity cos pi by 2 power t plus 1 by cos power 4 pi by 2 power t plus 2. So now pi is nothing but product of all these terms, right? So if I write the products, so let's say if I put t equal to 1, I will get cos pi by 2 square. So if I put t equal to 2, pi by 2 cube, t equal to 3, pi by 2 power 4. So on, cos pi by 2 power n plus 1, and we'll say n tends to infinity. This is only the numerator. So now we'll write the denominator also. So if I write the denominator, cos power 4 pi by 2 cube, cos power 4 pi by 2 power 4, cos power 4 pi by 2 power 5. So like that, cos power 4 pi by 2 power n plus 2. Again same, n tends to infinity, so no problem. So this we have to evaluate now. So if you see the numerator and denominator clearly, so after the first term, see from the second term, the second term in denominator is the same as the first term in numerator, second term in numerator is same as first term in denominator. So and we have power 4 here, only it's present once, so it is present 4 times here. So now we can cancel everything off. Only thing is that the first term in numerator will remain, cos pi by 2 square, everything will go off, and in denominator the last term will remain except that all terms are present 3 times. So, cos pi by 2 cube, cos pi by 2 power 4, so on cos pi by 2 power n plus 1. So, all these terms are present 3 times into the last term is present 4 times, cos power 4 pi by 2 power n plus 2. So, let us say now I want to simplify this. So, what we have here is cos pi by 8, cos pi by 16, so on cos pi by 2 power n plus 1. So, if I want to simplify this, I have to simplify using the, so we will use a relation here, cos theta, cos 2 theta, so on cos 2 power n theta is equal to sin of 2 power n plus 1 theta by 2 power n plus 1 into sin theta. So, this is the relation which we will use now. So, now if I use this relation, so here cos pi by 2 power n plus 1, cos pi by 2 power n, so on cos pi by 8. So, if we are writing pi by 8, theta is, so how many terms we are getting, we have to calculate. So, here theta is equal to pi by 2 power n plus 1, and we are having 2 power n into theta is, I mean here this is also n, right. So, we will make it t. So, 2 power t into theta is equal to pi by 8. So, 2 power t into pi by 2 power n plus 1 is equal to pi by 8. So, this is pi by 2 power 3. So, pi will get cancelled. 2 power t is equal to 2 power n plus 1 by 2 power 3. So, 2 power n minus 2. So, the number of terms here are t is n minus 2. So, this is 2 power n minus 2 into theta. So, here we will get sin of, so how many terms we have? So, 2 power, if you have 2 power n plus 1, here we will have 2 power n minus 2. So, if it is 2 power n minus 2, 2 power n minus 1 pi by 2 power n plus 1 by 2 power n minus 1 sin pi by 2 power n plus 1. Okay. So, this is sin pi by 4 by 2 power n minus 1 sin pi by 2 power n plus 1, and we have n tends to infinity, right. So, n is tending to infinity, we have to evaluate this. So, first we will evaluate limit n tends to infinity 2 power n minus 1 sin pi by 2 power n plus 1. So, as n tends to infinity, 2 power n plus 1 also tends to infinity. So, sin pi by 2 power n plus 1 tends to sine of 0. So, this is 0. So, 2 power n minus 1 will tend to infinity, infinity into 0 form. So, indeterminate form. So, we will make it determinate form. So, what we can do is, so just we will rearrange this, limit n tends to infinity sin pi by 2 power n plus 1 by 1 by 2 power n minus 1. We can write like that, right. So, into we are writing 1 by, so this will come to numerator only. So, 1 by 2 power n minus 1. So, we will make it 2 power n plus 1. So, we will multiply and divide by 4, multiply and divide by 4 in denominator. So, this will become limit n tends to infinity sin pi by 2 power n plus 1 by 1 by 2 power n plus 1 into 4. So, and then again multiply by pi and divide by pi, same, limit n tends to infinity sin pi by 2 power n plus 1 by pi by 2 power n plus 1 into 4 by pi. So, this whole thing will be 1 because sin theta by theta, and theta is tending to 0. So, this is the value of this is pi by 4. So, and we have only one term left here, cos pi by 2 power n plus 2. So, n tends to infinity, n plus 2 will also tend to infinity, 2 power n plus 2 will tend to infinity, pi by infinity is 0. So, cos 0 is 1. So, what we are left with is finally is the value of the limit is equal to, so limit value is equal to finally, So cos pi by 4 is in numerator, and in denominator we have cube of this. So we have to apply cube for this. So sin pi by 4, and again for the denominator what we have is, for the denominator we have pi by 4. So we can write as 4 by pi whole cube, and this is 1 power 4. So cos pi by 4 is 1 by root 2 by, this is 1 by root 2 whole cube into 4 by pi whole cube. So what will be left with is pi cube by 4 cube into 1 by root 2, 1 by root 2 will get cancelled, so root 2 whole square will be there. So it is pi cube into 2 by 4 cube is 64. So it is pi cube by 32. So the value of the given thing pi k equal to 3 to infinity 1 minus tan power 4 pi by 2 power k is pi cube by 32.